Okay, so really quick here, notice that we have cosine of 2x plus 3 sine x minus 2 equals 0. This right here is double angle of cosine. Remember I told you that depending on the problem, you're going to choose which rule for cosine you use. There's 3 rules for cosine, but because my other angle is sine x, I'm going to use the rule with sine in it. So we're going to be using 1 minus 2 sine squared x. That's how you can expand cosine double x. 2x. So let's go back really quick so you can see what I meant. So in part B, we have these options for cosine. So you had cosine squared minus sine squared. You had 2 cosine squared minus 1. And you had 1 minus 2 sine squared. So this is the one that we're using because you already have sine. Okay. And then we're going to have plus 3 sine x minus 2 equals 0. All right. Now, as you look at this, you should be like, oh my gosh, this kind of looks familiar. This kind of looks like something that I know. Well, it should look like a quadratic. So what I like to use is a form of u substitution. So we're going to let u equals u sine x. So we use u as sine x. It's going to look like 1 minus 2u squared plus 3u minus 2 equals 0. What that does is now eliminates the pressure of writing sine everywhere, and it makes it easier for you to see that this is something you should already know how to solve. So when I look here, I have 1 minus 2u squared plus 3u minus 2. I'm going to combine like terms, so 1 and negative 2, and that gives me negative 2u squared plus 3u minus 1 equals 0. Okay? So this is just now a simple quadratic that you have to factor in order to find the answer. All right. So now this goes back to, do you remember how to solve a quadratic? Okay. Solving the quadratic, you have a couple methods. You can solve it using the quadratic formula, or you can solve it by factoring, whichever is your preference or whichever is your strong suit of how you want to solve it. Before I solve, I am going to multiply everything by -1 just so that my leading coefficient is not negative. So by doing that, I'm left with 2u squared minus 3u plus 1 equals 0. Okay. So if I'm going to use the box method or quadratic formula, I'm a factor girl. So by heart, I want to factor. So I'm asking myself what multiplies to give me 2, but adds to give me -3. So what numbers multiply to give me 2, but add to give me 3? Pretend that's a really good drawn box. Oh, I can't even pretend. It's terrible. That was trash. Try again. Somewhat better. So we have 2u squared. We have 1. And so what multiplies to give me 2, but adds to give me -3, that's going to be a -1 and a -2. And I'll put u because that's what it is. So my factors would be like this. Remember, once you're in the box, you're just finding the GCF of everything. So the GCF here would be 2u to u. The GCF here would be -1. The GCF here would be u. The GCF here would be -1. So my factors are 2u minus 1 and u minus 1. Okay. And all this equals 0. Now remember, what does u mean? U is sine x. So now when I substitute back in for u, I'm simply solving 2 sine x minus 1 and sine x minus 1 equals 0. As we talked about before, when you have factors, that means you're taking each factor and setting it equal to 0 and solving it from there. So you're taking 2 sine x and setting it equal to 0. I'm going to create a little space for myself to work because I overrode and apparently not enough room here. So we have 2 sine x minus 1 equals 0, which is going to give me sine x equals 1/2, and sine x equals 1/2 in 2 locations. It equals positive 1/2 at 30-degree reference angles in quadrant 1 and in quadrant number 2. So that would be at pi over 6. So x equals pi over 6. and x equals 5 pi over 6 in quadrant number 2. I don't like how that equal sign did that. Okay. And then the next one that I'm going to do. So we now have sine x minus 1 equal to 0. So we're going to do sine x minus 1 equal to 0. So when I have sine x minus 1 equals 0, that means I'm looking for when does sine x equal positive 1? Well, sine x equals positive 1 at x equals pi over 2. And that would be my third answer. So from 0 to 2 pi, here are all of my answers and my possible solution. Again, remember, you could have used the quadratic formula also to come down to 1/2 and 2, 1, if that's what you chose to do. I went ahead and modeled it with factoring. Okay. Next is just more practice of solving. So in this one, you have sine x minus cosine x equals 1. For sine x minus cosine x, you have to determine how would you want to substitute or model this. This is a good example of how, again, you can use cosine x and substitute in something or sine x. So I would like you to figure out which puzzle piece you want to use to plug in, and then check your work and answer what you did compared to what was done in your notes on Canvas. Same thing for here, just to see how you would problem solve and what would you do to work through this, and then check yourself on Canvas. All right, that is it. Thank you.